Hi everyone, my name is Bhavishya. In this video we'll learn about ICMP protocol. So it's a supporting protocol of our IP, as IP was unable to do our flow control and error control. Disclaimer, when I'm talking about error control, I'm not talking about controlling the error or detecting the error. I'm talking about reporting about the error. So ICMP work as a error reporting protocol. Okay, so let me take an example. Suppose we have a sender connected to a router, and then router is connected to a receiver. Sender sends the datagram to our receiver, but unfortunately receiver dropped the frame. Now the receiver will send a message to our sender that the data is dropped. So this is how ICMP works. This was the ICMP message. So there are two types of ICMP. The very first is our error reporting message. The second is query message. So let me tell you how ICMP works. So in the datagram we see the very first is our IP header. Then we have initial 8 bits of the data. Then we have the rest of the IP data. So ICMP copies our IP header and our 8 bits. It encapsulates it with the ICMP header. It encapsulates it with our new IP header, as the older one was dropped and dead. So it encapsulates with the new one, and then it sends it to our sender, telling him that this particular IP address or this particular datagram was dropped. Okay, so let's jump into different types of error reporting messages. So the very first is destination unreachable. So there are two types of destination unreachable messages. The very first is destination host unreachable. So this is when, for example, I want to send the data to the receiver, but I'm unknown of its MAC address. So I'll basically do an APP request, right? So I'll do here. I did a ARP request, and the receiver was unable to send a response for it. So in this case, the data will be dropped. So this is when it will throw a error to us saying the host is unreachable, or the destination host is unreachable. The second part is when the destination port unreachable. This is when at the respective side of the receiver the process is absent. So this is when he will throw me a destination port unreachable message. So this was the first type. The second is source quench. Source quench is when, let's suppose there is a sender connected with many routers, and then our destination. So sender sends the data to our destination. Now in the intermediate router, let's suppose any router drops a frame because the buffer was full. So the source quench is a special type of error message, because it not only tells that the datagram was dropped, but also warns the sender that please slow down because our buffer is already full. Okay, and then the third type is our time exceed. So in time exceed we have two types. The very first is generated by the router, and the second is generated by the destination. Okay, so when it is generated by router, that means the time to live has reached to 0. So this is when it will throw the message of time exceed. The second is when generated by destination, is when destination is when, for example, is when the fragmentation has happened and the last fragment of the datagram is not received in the particular time. This is when it will throw the time exceed message. After that we have the parameter problem message. We have two types in them. The very first is when the header checksum we received is incorrect. or we detect any error, this is when it will throw us the parameter problem message. The second is when the SSR is set to some particular, let's suppose R1, R2 and R3 router, and R4 receives the frame, and as it sees that SSR is inbuilt in that, it will drop the frame. This is when we will receive the parameter problem message. And the very last is redirection. This is a special type of message because it not only redirect the datagram to the respective router, but also tells the source that you should not use this path, but you should use this particular path that I have chosen for sending the data. So this was it for the router. This was it for the error reporting message. Let's jump into query messages. So query message is when we have two types of message. The very first is reply. The very first is request, and the second one is reply. So we have pairs of messages. Okay. So sender sends the request message and receiver sends the reply message. Okay. So the very first is echo request and echo reply. So do you remember when we are doing the ARP request? In that we learned about ping. So ping is when we check the connectivity between the sender and receiver. So this is same. So when we want to check the connectivity between sender and receiver, we use this echo request and echo reply. Okay. So when we have checked the connectivity and connectivity is perfect, that simply means the intermediate router connected between sender and receiver are perfectly working, as they are perfectly receiving, they are perfectly processing, and they are perfectly forwarding the datagram. Okay. After that we have our timestamp request and reply. So this is a very outdated concept. Now we use FTP. So basically what does that timestamp, what use to this timestamp did was it synchronized the sender and receiver clock cycles. That's it. After that we have address, mask, request and reply. In this what basically happens is, let's suppose I have a host knowing its IP address but not its respective network mask. So I will send a address mask request to the respective router. He will reply me with the address mask. Now host know the IP is its respective IP address and also its respective subnet mask. Okay. And it will do AND operation with it, and now the host knows its respective network ID. Now let's suppose I want to communicate to B. I want to send some data to B. So as I know the network mask of A, I will AND the network mask of A with the IP address of B. With the AND operation, I will get to know the network ID of B. I will match the network ID of A and B. If the network ID is same, I will get to know if the communication is direct or indirect. So if in this case the network ID is same, the connection is direct. Now as the connection is direct, I will simply ARP B, will get to know its MAC address and will simply send the data to B. And at last we have router solicitation and advertisement message. So in this example, basically, let's suppose an host wants to send the data to our sender wants to send the data to receiver, but he didn't know that if the intermediate routers are alive or not. To know its information, he will broadcast the router solicitation message, and the respective router will receive it and will broadcast the router advertisement message. And in that router advertisement message, he will tell that if he's alive or not. If he's alive, only if he receives the frame. So basically he will send he's alive and also the information of all the respective routers he is known of. There is a fun fact that a router sends the what we say routing advertisement message periodically, even when the even when no one is asking for, to tell everyone that he's alive. So this was it for the ICMP protocol video. I hope you enjoyed.